Scientists are sounding the alarm. A new threat is approaching, and this time it's heading straight for the moon. Asteroid 2024 YR4, as big as a skyscraper, could collide with our Earth satellite in the coming months. No one knows exactly what would happen. The force of such an impact could cause enormous devastation on the moon with unpredictable consequences for us on Earth. There is no comparable data yet. We are facing a disturbing uncertainty. An asteroid as large as an average skyscraper in Manhattan is currently racing through the solar system. 2024 YR4 was discovered on December 27, 2024 by the Chilean Asteroid Terrestrial Impact Last Alert System. As an Apollo-type near-Earth object, the chunk is one of the objects that cross Earth's orbit and could potentially come close to our planet. On February 12, 2025, NASA issued an alarming warning that YR4 had reached level 3 on the Turin scale, the second highest threat level ever recorded for an asteroid. Hardly any other object has ever been rated so highly, not even Apophis or BNU. The exception is PAPIS 99942, which briefly reached level 4 in 2004. The Turin scale ranges from 0 to 10. At 10, our civilization would probably be doomed unless we could deflect the projectile or pull it out of its orbit. Level 3 means there is a significant probability of an impact that could cause major local damage, but not enough to turn the entire planet upside down. So 2024 YR4 gave us a scare at first. Then the all-clear was given. The value was quickly reduced to 1.6 by NASA, and finally the asteroid disappeared from the scale altogether. But now comes the new shock. Could 2024 YR4 hit the moon? Where does 2024 YR4 come from? And how did it get here? 2024 YR4 sounds a bit like the robot creatures from the Star Wars movies. And many space enthusiasts are wondering why this chunk of rock doesn't have a proper name, like the asteroid named after the underworld god AUS. The code is actually its real name. 2024 stands for the year it was discovered. Y stands for the second half of December, and R4 is a classification indicating that it is the 117th asteroid found during this period. Astronomers can immediately read details from the numbers that are not accessible to lay people. Ordinary people usually cannot make sense of the codes. So asteroids that are discussed in public are often given nicknames that are more catchy. Asteroid YR4 did not receive such a nickname, perhaps precisely because it sounds like a funny name for a kind of lovable android. However, the space rock is not really lovable. Its size of 53 to 67 m, its speed, and its mass would make it a city killer. If it were to hit Earth, it could wipe out a metropolis like New York or Berlin, or trigger a fatal tsunami if it hit water. After the all-clear was given, experts on Earth breathed a sigh of relief. Although we are working worldwide on an asteroid defense system and in theory already have the means to protect ourselves, no one on Earth wants to see such an emergency happen. But now comes the new headline. Data from the James Webb Space Telescope shows that its trajectory has changed, and there is now a 4.3% chance that YR4 will collide with the moon on December 22, 2032. If YR4 were to actually hit the moon's surface, it would have no effect on our satellite's orbit. The asteroid is too small and the moon too large for that. However, we don't know exactly what the effects of such a collision would be. We know very little about the connections between the moon and Earth. A major impact could plunge Earth into a state of natural disasters, extreme weather, and climate disruption for months or even years. What would happen to the moon? The moon has no weather as we know it, no water, no cities, and no inhabitants. However, there are mountains, valleys, ancient impact craters, and above all, lots of dust on the moon's surface. A large impact could cause as much turmoil on the moon's surface as it would on Earth. Landscapes would be destroyed or altered. The moon has no atmosphere, which means there is no air friction to hold the dust back. When an asteroid hits the moon, the impact can stir up large amounts of dust and rock, which are then hurled into space. The impact can also trigger secondary effects such as moonquakes. This raises the question of whether moon dust and rock could pose a real danger to us. The answer is yes. Depending on their speed and direction, some of the dust and rock could reach Earth, or they could hit satellites, the James Webb Space Telescope, or space shuttles. If the moon experiences extreme changes such as a series of quakes and tremors, its gravitational influence could change slightly for a time, and we don't know to what extent this would affect its interaction with Earth. All in all, such an event would be an adventure. We would certainly prefer to observe it from a reasonably safe distance on the moon rather than be affected ourselves. 100 Impact on the Moon, ESA's Neliota project. Imagine the Moon as an active research laboratory for asteroid defense. Since it has no atmosphere, even the smallest celestial bodies strike its surface unfiltered and with full force. The European Space Agency, ESA, is using precisely these impacts to expand our knowledge of asteroids and meteoroids. With the NELIOTA project, Near-Earth Object Lunar Impacts and Optical Transients, ESA has developed a system that makes it possible to record these fascinating events in real time. By observing short flashes of light that occur upon impact, we become witnesses to these silent acts of violence. Since the project was launched, over 100 impacts have been documented. Many of them lasted only a few seconds, but were bright explosions that were only visible to highly sensitive telescopes. A particularly impressive event was recorded on March 1, 2020 by two distant observatories, the Sharjah Lunar Impact Observatory in the United Arab Emirates and the NELIOTA telescope in Greece. The impact was bright, short, and sharp. Recordings show a quick flash of light that lit up the dark surface of the Moon for a fraction of a second. The impactor probably weighed only a few kilograms. But at a speed of over 72 kilometers per second, it quickly turned into a glowing fireball that surely reached temperatures of several thousand degrees C. Such events are impressive forces of nature, and they are valuable to us on Earth because they provide crucial data for asteroid research. By analyzing the flashes of light in detail, scientists can draw conclusions about the size, speed, mass, and composition of the impact bodies. This data is fed directly into databases and ultimately becomes valuable knowledge when it comes to defending our planet. The better we understand how often and how hard such bodies strike, the better we can identify future threats, and perhaps one day even ward them off. NASA is also actively involved in observing, evaluating, and collecting data on lunar impacts through its Lunar Impact Monitoring Program together with ESA and other space agencies from many countries. This is creating a global network that turns the Moon into a kind of early warning system for asteroid hazards. Only these telescopes can warn us about asteroids. Asteroids are treacherous visitors, mostly dark, small, and sometimes extremely fast. In order to detect them early and better understand their impacts, for example, on the Moon or Earth, scientists rely on specialized telescopes and sophisticated early warning systems. Not every telescope is suitable for asteroid observation. Classic observatories focus on point-like and distant objects. Asteroids are relatively close, move quickly against the backdrop of the stars, and are often small and faint. This is why particularly sensitive wide-angle telescopes with automatic motion detection are used for asteroid observation. One of the most important facilities is the Pan-STARRS telescope system in Hawaii. Every night it scans large sections of the sky and detects even the smallest movements. In 2017, Pan-STARRS discovered the strange object Oumuamua, which passed by Earth at breakneck speed. The Atlas system, also stationed in Hawaii, was specially developed to detect smaller objects such as asteroids or comets before they hit Earth. Another highlight is NEOWISE, a repurposed NASA space telescope that operates in the infrared range and can therefore detect particularly dark objects that are barely visible to optical telescopes. At the global level, we already have 3 highly functional asteroid warning systems. NASA's Planetary Defense Coordination Office, PDCO, is responsible for coordinating U.S. asteroid monitoring and defense. The data is, of course, exchanged with other organizations in real time, and warnings are issued worldwide. The ESA's Near-Earth Object Coordination Center, NEOC, in Italy is the European counterpart and works closely with NASA. With the IAWN, International Asteroid Warning Network, many nations around the world have created a global network of observatories and institutes that exchange real-time data and jointly analyze potentially dangerous objects. These systems work hand in hand with specialized telescopes, satellites, and data centers. In the age of digital astronomy, the sky is scanned night after night with pixel-perfect precision. And in the event of an alarm, all responsible authorities around the world are notified within minutes of a threat emerging. The goal of planetary asteroid observation is clear. No potentially dangerous celestial body should remain undetected, and even smaller objects should one day be detected in time before they strike or explode in the atmosphere. In 2013, the Chelyabinsk asteroid gave us a scare. Only a few meters in size, it appeared without warning and exploded over the Russian city. Thousands of people were injured and many more suffered shock. This asteroid was simply too small to be detected with existing technology, but scientists are working hard to detect such projectiles early in the future and, in the best-case scenario, destroy them before they enter the atmosphere. Another dramatic example that shows how important early detection is. is the so-called Tunguska event, in which a meteor destroyed an estimated 2,000 square kilometers of forest in Siberia in 1908. If this space rock had hit an inhabited area, it could have killed tens of thousands of people. With an estimated diameter of 50 to 80 m, the Tunguska meteorite was at the lower limit of what today's asteroid monitoring systems can reliably predict. In plain language, this means that despite the warning systems currently in place, the force of such destruction could still take us by surprise.